Next method is joint sensing. It's a indirect method to calculate force. So we are calculating torque. Again, this torque is calculated from the current. If the robot uses DC servo motor, it's very useful. If the robot uses DC servo motor, then torque being exerted by the motors is proportional to the current flowing through the armature. So we can identify or we can measure this current. So how can we measure this current? A simple way to measure this current is to measure the voltage drop across the small precision resistor in series with the motor and power amplifier. So we can put a resistor in between power amplifier and motor. We can take the voltage drop. So this voltage drop is proportional to current, and this current is proportional to torque. Again, this torque is proportional to joint. So it's a very indirect way of sensing or measuring, but it's very simple. So main advantages is this construction and measurements is simple. It's very simple method, and it is more useful with the direct drive robots. Joint torque sensing is more useful with direct drive robots. So what is a direct drive robots? Direct drive robots are drives is directly attached to these joints, that is without any transmission device. So power can be transmitted either using directly or using some kind of mechanism. In the direct drive robots, drive motors are located at the joints of the manipulator. It's directly connected to the joints. So in this method, in torque sensing method, this configuration reduces the friction and transmission loss. That is, there is no power transmission device such as gear, belt and chain. So friction also reduced, and problems of torque measurement which accompany these losses are thereby reduced. So it's very useful for direct drive system, but if there is some power transmission device, we cannot go for it. So its drawback. So first drawback is it's a very indirect way of measurement. That is, measurements are made in joint space. So we are taking measurements in DC motor, but actually we want to measure the tool space. So measurements are made in joint space, while the force of interest are applied by the tool and would be more useful if made in tool space. So we need the calculation, or we need the measurement from the tool space. So we need to calculate force exerted by the tool and object, but we are calculating in indirect way. So in this kind of measurement, this measurement therefore not only reflect the force being applied at the tool. Actually we need the information from the tool side, but also force the torques required to accelerate this link of the arm and overcome the friction and transmission loss of the joints. If it's a direct drive system, we can avoid these loss, that is friction loss and transmission loss. Otherwise we have to consider these loss. So these are the drawback. So joint sensing mechanism is very simple, but it's an indirect method.